In the name of God. Hello, dear students of grade 7. Welcome back to Thinkable Physics YouTube channel. I am Masood, and I want to be with you with one more subject about the states of matter, which is gas behavior. Let's get started. The title of our subject is gas behavior. So, as previous lessons, I read the subject, I read the text, and I want you to bring your science book in front of yourself to highlight the important information. Right, let's get started. Suppose you are watching a parade that you have been looking forward to for weeks. So, parade means exhibition, fair, show. You may be fascinated by the giant balloons floating high overhead. So, the parade is about showing the giant balloons in public. You may wonder how the balloons were arranged for the parade. How much helium was needed to fill all of the balloons? So it attracts our attention by asking some questions. The first question talks about the quantity of helium needed to fill the balloons. The second question says what role does the weather play in getting the balloons to float? Weather. So does weather have to do with the size of the balloons? Is weather actually related to the inflation of the balloons? Let's read it. Helium is a gas. The first information: helium is a gas. Is a kind of gas. Is a kind of gas. Gases behave differently from solids or liquids. Of course, you know that each state has its own characteristics, right? Unlike the particles that make up solids and liquids, gas particles have a large amount of empty space between them. You know this information because I explained it for you. There's a big gap between two neighboring particles of gases. The space that gas particles occupy is the gas's volume. This is the definition of volume. A space taken up by a gas particle. And it's not just for gas, actually. The volume of any object is defined as this. How do you define the volume of any object, for example? It's a space taken up by an object, a space occupied by an object. For example, think about your body. Does your body occupy space? Of course, yes, right? The size of your body represents the volume of your body. This is called volume. But particularly our concentration in this text, at least in this paragraph, is on gas, right? It says the volume of gas is a space taken up by particles of gas, which can change because of temperature and pressure. So it refers to the what? It refers to the volume of the gas. So what thing changes because of temperature and pressure? Volume of gas changes. I want to add one expression here, which is gas volume. So gas volume changes by changing two factors. What are these? Temperature and pressure. The first factor is the temperature. Let me change the color. The first factor is the temperature. Changing temperature gives rise to the changing volume of the gas, right? Changing pressure leads to the changing volume of the gas. So this is about the first first text or introduction of the gases. But I want to draw the simple array of the particles of gas. After that, we will move to the volume. Let's move on to the whiteboard. Right. We said that between two neighboring particles of gas, there's a big gap. That's why gases are compressible, right? This is background for us. I'm gonna draw some particles here. The first particle, the second one, you see there's a big gap. The third one, and the other particles, right? And we said that they move very, very rapidly in all direction. So we have a random motion of the particles of gas. You cannot predict the direction of the particles of gas. So particles move in all direction, actually in a, let's say, with rapid motion and freely, actual movement, right? Freely movement. Let me actually draw the, for example, so what's this? This space is called volume. The space taken up by the particles of gas is called volume of the gas. So this region is the volume taken up by particles of gas. This is about the first, actually, first paragraph of our subject, right? Let's get back to the text. Actually, right now we have we want to study the volume particularly. We concentrate on volume right now. Volume of gas, especially volume of gas. Let me read the subject for it. It says volume is the amount of space that an object takes up. This is the general definition of volume of any object. Volume is the amount of space taken up by an object. But because the particles of gas spread out, the volume of any gas depends on the container that it means actually the volume of the container is as the volume of the gas, right? For example, have you ever seen inflated balloons that were twisted into different shapes? Shaping the balloons was possible because particles of gas can be compressed or squeezed together. Let me highlight this information. So, shaping the balloons filled with gas is possible, right? Because gases are compressible. You can compress the gases because there's a big gap between two neighboring particles. That's why you can shape it as you wish. You can twist it, you can actually squeeze it, you can shape it, right, into a smaller volume, right? If you try to shape a balloon filled with water, the balloon would probably explode. I'm not going to explain this line. It would explode because particles of liquids cannot be compressed as much as particles of gas. I wanted to highlight this information from here. Particles of liquids cannot be compressed. So compressibility is one behavior of gases, not for liquids. Gases can be compressed, but liquids cannot. You cannot compress the liquid, but compressibility of gas is possible. About the shaping the balloons filled with water and filled with gas, I want to do some simple experiment for you. I want you to be with me. For example, we have a balloon filled with gas, right? I ballooned it with air. I ballooned it up with air. So right now we have a balloon filled with air. We want to actually shape it. Is shaping the balloon filled with air is possible? Yes, of course. So you can shape it. Is squeezing possible? Let me squeeze it and twist it. So I want to twist it. So twisting the balloon filled with gas is possible. So right now we have what? Right now, uh, so shaping the balloon filled with gas is possible. What do you get from this simple experiment? It means gases take the shape of the container. It means shape of the gas is indefinite. So we have the indefinite shape for gas. One more thing, if you put a microscope above the particles of the gas inside the balloon, you observe that the gaps reduce. Particles come closer to one another. What do I mean by gaps reduce? Particles come closer to one another means the gas volume changes. It means actually the gas is compressed inside the balloon. This is about. So let me do one more experiment about the balloon filled with water. So this balloon is filled with water, right? I want to shape the balloon, and the balloon is filled with water. If you try to shape the balloon, actually you can shape the balloon very easily. That's why actually shape of the balloon filled with water is possible as well. What do you understand from this experiment? It means actually shape of the liquid is indefinite. Liquid takes the shape of the container. But what do you say about the volume of liquid? Volume of liquid does not change. What do I mean by volume of liquid does not change? It means volume is definite for liquids. So liquids have definite volume. It means if you put a microscope above the particles of water within the balloon, inside the balloon, you see that the particles gaps don't change. Separation between the particles don't change. It means volume remains as it is, unlike the gases. So keep in mind that liquids have indefinite shape but definite volume. But gases have indefinite shape and indefinite volume. Right. So we are about to finish the lesson, except for one more information. There's a mistake in the definition of volume. I want to correct it for you. Be with me to, if you read the definition, it says a measure of the space take place by the object. Actually, it's not take place, measure of the space take up, right? Measure of the space take up by the, I'm gonna erase this one. I want you to erase this. Measure of a space take up. I want you to write take up, right? Write take up here, take up. Measure of a space take up by the object. That's all for today, guys. Thank you very much for watching this video, and bye bye.